Hello, and welcome back to A3 Math. Today, we're completely switching gears, and instead of talking about quadratics and factoring and all the fun stuff we have been talking about, we're going to look into probability. We're going to talk about probability. Before we do so, we should probably define what probability means. So probability is how likely a favorable event will occur out of the total possible outcomes. So this is a definition we want to engrave in our memory, because for all probability questions, they're all gonna be about this definition. So this definition is it is the key definition or the key concept that we're going to take with us through the entire unit of probability. So again, how likely a favorable event will occur out of the total possible outcomes. So let's look at a scenario. Scenario A is asking for what is the probability that a student chosen at random from a class of 40 is a boy? What is the probability that a student chosen at random from a class of 40 is a boy? So right away, it's asking for probability. Now, probability is the total possible outcomes and the favorable possible outcomes, right? We need both of those. So total possible outcomes and the favorable outcome, right? Definition. So our total outcomes, well, you're choosing one student out of 40. So our total outcomes, it could be any one of those students. It could be any one of the 40 students. Our favorable outcome is if we choose a boy. But do we know the makeup of this 40? No, we don't. We don't know how many are boys and how many are girls. So in this scenario, to solve for probability, we would need to know if there's, in the class of 40, if there's 20 boys and 20 girls, or 10 boys, 30 girls, we need to know the makeup of the class. So in this case, we cannot solve for probability because we're not able to determine our favorable outcome. All we have is our total outcome. It could be any one of the 40 students. Let's try scenario B. Well, scenario B is asking for the probability that flipping a coin will land on heads. Now, you might already know that it's a 50-50 chance, one out of two, right? But let's go ahead and talk about it with our definition in mind. So what is the total outcome? What is the total outcomes? Well, there's two. There's either heads or tails, right? Heads or tails. Those are the only outcomes we could have, unless it lands on the side. Doesn't matter. The only outcomes we have is heads or tails. So our favorable outcome is heads. How many favorable outcomes are there? Well, there's one, right? There's one. This is where we would get our 1 over 2, our favorable outcome, all over our total outcomes. And 1 over 2 is 50%. So this is where we would derive our answer. We would derive it from our definition that we talked about previously, and we're going to apply that again to all our questions. So scenario C, in a single throw of a 6-sided die, what is the probability of A, a number less than 3? So let's first determine our total outcomes. Let's determine our total outcomes. So if we throw a 6-sided die, well, numbers from 1 to 6 are our total outcomes, right? We could roll a 1, a 2, a 3, 4, 5, or a 6. So how many outcomes are there? Well, there's 6. There's 6 total outcomes. So for A, we need to determine first our favorable outcomes. Our favorable outcomes is a number less than 3, which is just 1 or 2. So there is only 2 favorable outcomes. Again, 2 out of 6, right? Out of our 6 total outcomes. So our probability is 2 over 6, or 1 over 3. B is asking for a number greater than 4. Again, we're going to want to determine our favorable outcomes. Our total outcomes remains the same because we're still throwing the six-sided die. So our total outcomes remains 6. Our favorable outcomes, a number greater than 4, well, that's only 5 or 6, right? Again, there is only 2 favorable outcomes, giving us a probability of 2 over 6 or 1 over 3. Okay, what about C? C is asking for a number greater than 6. So again, we're going to write out our favorable outcomes. Number greater than 6 on a six-sided die, well, we talked about all our total outcomes. There's no number greater than 6. We can't roll a 7 and 8. So favorable outcomes is 0. Again, we have 0 over 6 or just 0. D is asking for any odd number. D is asking for any odd number. So simply, we're going to write out our favorable outcomes. We have 1, 3, and 5, giving us 3 favorable outcomes. Total outcomes, again, is 6. So we have 3 over 6, or simply 1 over 2. And question E is asking for any number except for 5. So no problem. We're just going to write out our favorable outcomes. Any number except for 5. 1, 2, 3, 4, and 6 are all favorable to this question. So we have 5 favorable outcomes, giving us a probability that we will roll any number except for 5 to be 5 over 6. And finally, question F. Question F. F is asking for the probability of any number between 1 and 6. So, favorable outcomes is any number 1 to 6. So 1, 2, 3, 4, 5, and 6, giving us 6 favorable outcomes. Again, our total outcomes are still 6, so 6 divided by 6, giving us 1 or 100% chance. Let's go ahead and try a harder example. I want you to try it on your own, and then restart the video when either you get stuck or you have a final answer. So at first, we're asked to list the possible outcomes if 3 coins are tossed. And then it's asking for the total number of outcomes. So with questions like this, I like to make a tree diagram. It helps organize my thoughts, it helps organize the question, and it looks nice. So for a tree diagram, in this question, we're asking if 3 coins are tossed. So we have our first coin, our second coin, and finally our third coin, right? So our first coin has 2 possible outcomes. It could either be a heads or a tails. Our second coin could be a heads or a tails. But also, if the first one is a tails, it could also be a heads or a tails. Finally, our third one could be heads or tails. If it's heads, tails, and then the third one could be a heads or tails again. And similar on the bottom coin as well. So tails, tails, it could be a heads or a tails. So I hope you're able to see how I derived our tree formula. So or a tree diagram, sorry. It's just a way to express each possible outcome as the question progresses. So the first coin, we could only have a heads or a tails, right? The second coin, depending on how the first coin was thrown, we have different options, right? We have heads or tails here, but if the first coin was a tails, we also have heads or tails down below. And finally, the third coin, it's just amplified because the second coin has heads or tails as well as the first coin. So our possible outcomes right? Our possible outcomes, we just read across our entire tree diagram. So heads, heads, and heads is one of our outcomes. Heads, heads, and tails. And then heads, tails, and heads. Heads, tails, and tails. Tails, heads, and heads. Tails, heads, and tails. Tails, tails, and heads. And finally, tails, tails, and tails. So it's not so bad since we only have 3 coins, but if we had more coins, we would want to do a tree diagram to help organize all our thoughts and making sure we don't miss out on any of our possible outcomes. So the question is asking, what is the total number of outcomes? Well, that's simply all of our possible outcomes. In this case, it is 8. We just simply count our total possible outcomes. 8. So question 2 is asking how many outcomes with 3 heads? Well, we just looked down our possible outcomes and we found one, just one, with 3 heads. How many outcomes with 3 heads? There's 1. Now it's asking for the probability of getting 3 heads. Well, what's our favorable outcome? It's getting 3 heads. How many outcomes are there? Well, there's simply 1. Right? There's simply 1. And we're going to divide that by our total possible outcomes, which is 8. Something we calculated before. So that is the probability of getting all 3 heads. And finally, what is the probability of getting no heads? So if we go back to our tree diagram of our possible outcomes, how many have absolutely no heads? Well, it's only 1, and that is tails, tails, and tails. So the probability of getting no heads is 1 over our total possible outcomes, which is 8. And that's it. We just solved a harder question that had to do with probability. So the main thing to take away is the definition of probability. It is the number of outcomes of a favorable event all over the total possible outcomes.